Hello there, my name is DOH-NANI from the Department of Statistics and Actuarial Science, KNST, Kumasi, Ghana. Yes, so today is yet another day and we would want to talk about some interesting topic in pure mathematics, that is calculus. And under calculus there are two subdivisions, or calculus is basically dependent on two subdivisions, that is differentiation and integration of a function or an expression. But before then, please kindly subscribe to this channel, click on the notification bell below, kindly comment, share and like the video as well. Yeah, so we are going to talk about the differentiation and integration, a simple differentiation and integration based on these expressions or functions. So we are going to talk about the linear function, the quadratic function, as well as the polynomial function. Then we will tackle something small about some special functions. Now, to talk of the linear function, So basically, the linear function is having the dependent variable and the the independent variable, and thereby say f of x or y is equal to say ax plus b, and in this case the a is serving as the gradient and the b is the intercept. So having an xy plane or a two-dimensional plane, and seeing there is a straight line, seeing to it that there is a straight line passing through the somewhere on the y-axis and any other place on the x-axis. This is my origin and this is my x-axis and this is my y-axis. So here is my y, which is equal to ax plus what? B. And I said earlier, our b is the intercept as well as where our a is gradient. So our a is simply the change. Our a, this one is the change in y over the change in what? X. So our a is equal to the change in y over what? The change in x. And we are basically looking for the changes, that is the gradient. So in differentiation, dy dx is equal to the change in y over what? The change in x. So given an expression or a linear function such as this, y is equal to ax plus b, so we simply want to find for the expression the dy, the change in y with respect to the change in x, will give us a y. In differentiation, we consider the independent variable and then simply, given this expression, simply ax. There is a superscript 1 here, of which is an imaginary, or it is not shown over there, so plus b. Then we just, in finding for the dy dx, we just a times 1. That's, there is that one, we multiply it by a, then x. That is 1 minus 1. We subtract 1 from the expression. Then we cancel out this because it has no independent variable, giving us a, because here will be x exponent 0, and any number exponent 0 is 1. So here becomes 1, giving us a. That is why dy dx is equal to a for a linear function. Yeah, so and again, we can see that for the expression, after finding the derivative of the function, we are going to get a constant value, or a specific value, or a point. Say if I'm given a function y is equal to 2x plus 3, when I should differentiate y with respect to x, so dy dx, I'm going to get 2. It's just a single value for the change of y with respect to x. Now let us go on to the quadratic function. So quadratic function has to do with the power, with the independent variable with a power of 2, or beginning with a power of 2. So given an expression f of x is equal to x squared, say ax squared plus bx plus c is a quadratic function because we are having the power of the first points to be 2. And another reason is that this can also be drawn as, this can be drawn in this direction, or so a quadratic function could be in this shape or this shape, could be in this shape, y-axis and the x-axis, y-axis and the x-axis, moving from the origin. Yeah. So another thing is when we are to differentiate this expression, say this is my y. So I'm differentiating the expression over the expression x. So I'm going to end up getting this 2 multiplying by a. So it will be 2 multiplied by a, then x. So there is 2 here, so 2 minus 1. The superscript 2 minus 1 plus the b. So b multiplied by 1 because there is a power 1 over here which is not written. So 1 minus 1. Then plus c, but this time around it has no variable, so we discard leaving it this way. So at the end of the day, we are going to get dy dx to be equal to 2a x then plus b. And here, what do we see here? You see that after the derivative, we had x, or the variable still in the expression, meaning that it has no it has no one point. Meaning that at the point when we are looking for the change here, you draw a straight line on the curve. And in this case, we are going to draw another straight line. So this line is referring to the change when we are moving across the curve. There is going to be another line. There is going to be another line, and so on and so forth. So this is basically the line. This one is a straight line. When you start to put in some values for the independent variable, you are going to get a point at each line, or as you move along the curve. And when you want to find out where the turning point of the curve is, that is when you equate your dy dx. That is, there is no change, and you can realize that at the bottom, or the maximum or minimum, you will get the changes to be equal to 0. That means the change of y on the change of x is equal to 0. So thereby you equate it and find the specific point on the x plane where the change, or there isn't no change, or the turning point is, on the curve. So we shall get some questions. Some questions will be given after we complete with the explanation, the concept. Then we will know how to go about them. Now we are going to talk about polynomial functions. And with polynomial, we have when the expression f of x or y is equal to or f of x, which is x cubed ax cubed plus bx squared plus cx plus d, and this is a polynomial function. F of x can also be x cubed, is a polynomial function. F of x can also be ax cubed plus cx plus d, is also a polynomial function. F of x can also be ax bx squared plus c, then plus 2x. And resolving this or finding the simplifying this, you are going to end up getting abx cubed plus acx, or acx plus 2x plus c, in thereby getting abx cubed plus ac plus 2 multiplying by x plus c. And this expression is also a polynomial function. That was just by the way. Now, to differentiate a polynomial function, as the first one, or how I did the first explanation with the linear and quadratic, there is no difference in it. We just have to do the simple differentiation. So dy on the x, the change in y with respect to the change in x, is equal to 3ax squared plus 2bx plus c, and this will be the derivative of this expression. That is just it. And with polynomial, it has this shape on the xy plane. With polynomial, it has this shape on the xy plane. So it can form this way, any shape on this, and this will be my y is equal to f of x. Then this is my x axis, and this is my y axis. So basically, it can fall within these shapes, and it has two turning points. It has two turning points for polynomial, but for quadratic, it has only one turning point. And with quadratic, linear is only a line, with having its gradient to be a single point. But for quadratic, it has several change or several gradient as far as the line is concerned. Okay, so some examples. Differentiate the expression a y is equal to 2x plus 3, b y is equal to 3 on 2x squared plus 3x, c y is equal to say 4x cubed plus 2